Welcome to the MSSQL Tips webcast. Voice of Experience. SQL Expert shares 5 best practices for SQL Server HA in the cloud. Sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MSSQL Tips, and today's webcast host. The presenter for today's webcast is Heath Carroll, who is a SIOS software engineer. Heath provides the SIOS engineering team with in-depth expertise in cloud deployments, and today he will share his SQL Server experience working with the cloud. Before we get started, if you have a question, you can submit them at any time during the webcast by entering questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you're not already a member of the MSSQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Heath, and he can get started.
Thanks, Greg. All right, hi, my name is Heath Carroll. I am a software engineer at SIOS, and these are some tips that we've gathered together for the best practices for having SQL in the cloud, basically. All right, so a little bit about me at first. We have some templates available for you guys to use up in both Azure and AWS. We have not gotten to the Google Cloud domain yet, but we may get there if interest seems high enough. We've deployed dozens, if not hundreds, of these deployments for customers. We have 2 professionals that just help customers deploy things with templates at this point, along with a whole bunch of other things that they do. Hopefully these templates have helped them out. So my other responsibilities besides working on the cloud and some templates include some Windows driver development, some service work, C# and C++ code mainly, and anything that we do in PowerShell. I do have a master's in engineering from the Comp Sci department at the University of South Carolina. I also have my bachelor's of science in math from the University of South Carolina. And my research area for my not yet acquired PhD is in network security. I do have 2 amazing children. These are them, Zelly and Fiona, ages 5 and 8, with their Halloween pumpkins for this year. And when I'm not being a parent and I'm not at work, these are some of the things that I like to spend my time on, all 1 or 2 hours a week that I have. All right. So now that my introduction is over, I would like to get to know a little bit more about the audience. Greg's gonna queue up a question for you guys, and here it is.
All right, the poll's launched, so everybody can just take a couple seconds and just answer these, and then we will read the responses. I'm going to give another 5 seconds and I'll share the results. And I apologize for not allowing you to select 2. All right, let me close that down and share the results. So we have 56% said no, 29% yes using Azure, 13% using Amazon, and 2% using Google.
Okay. Thanks, guys. So it's fairly spread between Amazon and Azure, I guess. All right. So a big thing that people like to do these days is move existing SQL deployments into the cloud from a physical setup, or possibly even from virtual nodes that they have on their physical hosts on location somewhere. It's not a too terribly hard task, but it's not trivial. You don't just simply do it, though. It requires several steps. A lot of it requires some IT background, and considering that I think most of the audience is also a SQL DBA of some level, it requires a good deal of SQL knowledge so that you can actually make sure that your data is available once you get it on site in the cloud. All right, we do have some folks available to help if at any point you guys decide to migrate to the cloud and you would like to use something that we've put together in Azure or AWS. You can contact both David Birmingham and Mike Trout. Just email information and phone number for those guys is on the right. They'll be happy to help. All right, so why? Why do we want to do all of this? Why even bother with the cloud? Well, the cloud has its pros and cons. I think the pros at this point slightly outweigh the cons, but I like physical machines, so I'm in the minority at this point. Some of the things that the cloud touts are cost reduction, the ability to reduce the amount of IT staff you have on site, potentially completely. I would not go completely, but whatever. In reality, ease of use is another one that's really a big deal. That's really come into play with things like these production templates. Until the templates were there, ease of use was not a pro. It was not there. The templates really do help you out on that front, but you still need someone that knows what's going on in whatever cloud domain that's being accessed. So if you've got Azure as your target, then you need to have somebody, your IT specialist that you've got on board, needs to be up to speed in Azure. Same thing with AWS or Google. Our product in particular is one of the few things in the AWS Azure cloud space that allows you to have local volumes exposed as shared storage in the cluster and failover cluster. So there is another one, SQL Always On. It's about we're the only two real options for shared storage in Google or in a failover cluster. So really the option is there. So why not use SQL Always On? Well, SQL Always On isn't quite as robust as our product. Our product is mainly focused on any data whatsoever, as long as it's on a volume inside of an OS. So we didn't focus it just on SQL, whereas SQL Always On is obviously isolated to just SQL. So if you've got data that's not SQL, you pretty much have to go to us. If you've got the need to protect the actual system databases that get installed whenever you install a SQL instance, you pretty much have to go to us. There's a little bit of limited functionality there with SQL Always On, but it's nowhere near as robust as our product. DataKeeper really is, I mean, it's an overall solution for any shared storage you need in the cloud, honestly. Microsoft's got S2D coming up, but so far it's not really working out too well from what I can tell. I think I'll turn this over to Dave Birmingham in a little bit, and he'll be able to add some to this if there are any questions about it at the end. All right, so if you're migrating SQL to the cloud, or if you're just creating a new SQL instance in the cloud, don't do it alone. While the cloud and deployment templates have made things a whole lot easier, I have not had to manually install SQL in a very long time, and that is one of my happy places. I originally started when I started installing SQL, doing it with the GUI, just like everyone does, and then moved on to doing it with the scripts from the command line. But now I don't even have to do that. I'll show you guys later. It takes me about 30 seconds to launch a 2-node cluster with SQL installed. I mean, sure, I got to walk away and have a coffee break or something for 2 hours while it loads, but the actual me time with the computer is almost zero. It's less than a minute. All right, so you need an IT person that's knowledgeable in AWS or Azure or whatever cloud you're using. I would recommend finding a template. There are templates for SQL. There are templates for DataKeeper. There are templates for pretty much anything you could want in the cloud, both Linux and Windows. So if you need it, they've got it. You just have to make sure that you find what you need before you deploy it. All right. So that's one of the things that requires you still have to have an IT person, and they need to be knowledgeable about the cloud, and that's why you need them, because they'll be able to like find the thing that you need to deploy, and they'll be able to understand what it's doing when it deploys. Routing tables, IP configurations, subnetting, all of that stuff still needs to happen in the cloud. It's just now it can be automated by someone who's extremely knowledgeable about the topic. You don't have to have someone on site that knows that.
I was trying to figure out what was going on with that. Okay. Oh, we want to make sure.
We're good?
Yeah, we should be good. Sorry about that.
Okay. All right, so if you guys do find a template that you want to deploy to get you guys started in the cloud or to migrate you into the cloud, there are still all of these things that you really need to worry about. Things I already mentioned: routing tables, security groups, basic IT settings. You still need to keep on top of things like security, and even with the data replication product in the cloud, which is supposed to be durable and have high availability just by its own nature, you still have to enable other things to actually give yourself protection, to actually give yourself high availability, and to actually have your data be secure. You still need to do backups. You still need to do data replication. They don't do that stuff for you, really. So you still have to have someone that knows what they're doing in that realm as well. All right, so this part right here is one of the big takeaways from this. Make sure you've got an IT that knows how to do these things. All right, brief story. In the past few months, specifically messing with templates, I've come across two different scenarios that I think will contribute to this discussion. One was a couple months ago. I wasn't involved a whole lot with it because the customer was a little hesitant to listen to us when they got us on the phone. But we had a customer that deployed a test environment. Then they deployed to production. When they were in test, everything worked fine, but then they deployed it in production. Neither time did they use an actual template for this. They just did it by hand with handwritten steps. And when they got it in production, it didn't work. So they assumed that it was our fault because the only thing different between test and production was DataKeeper. I'm not sure why there was a difference between test and production, but there was. But that wasn't the only difference. The other difference was that they only had one node. I'm not sure how they were expecting replication to work with only one node in their test, but they didn't install replication anyway, so it didn't work. So then when they got the deployment to the production system, they had two nodes, replication going on, or they wanted replication to be going on, but for some odd reason they couldn't get to the second node and they couldn't figure out why. Well, we got on the phone call and my boss called me into the room about 10 minutes into the phone call and showed me a couple of things, and I was like, oh, they've got something wrong with their routing setup in the network. It's either in the VMs themselves or it's in AWS, because this was the system up in AWS. And he said, okay, sweet. And then we sat on the phone for another 10 minutes trying to communicate to them, and it just didn't get through. They wouldn't listen to us, that we were telling them what was wrong. They were assuming it was something to do with the product and not something to do with their setup. So we just went back and forth for another 7 hours, I think, until our end of the day happened. And so we left and they started talking to Microsoft, or not Microsoft, started talking to AWS. This was a Linux system. Started talking to AWS, and AWS pointed out, after we had already pointed out, that their routing table was busted, and so was one of their security groups in AWS. We had, in the 7 hours that we spent with them, tried to get them to show us and fix both of those, and they just wouldn't. Until the very last minute, when we've got one person that's in after hours talking to them on the phone with AWS after we spent all day working on it. All right, so morals of the story: the cloud is hard. It is not a one-stop. You can do it without having any knowledge to be gained. You have to know what's going on. There are people that's entire career is nothing but this. Listen to the experts when it comes to this. It's hard. I understand it's really hard to go, I know what I'm doing, I did this, and then have someone go, yes, but I think it's broken. You got to swallow it and listen to them anyway. More morals of the story. If they had used a template, then they wouldn't have had to hand do all of this stuff one way and then not do it the same way on the other side. They could have just done it the same way once and done it the same way the second time, and there would have been no problem. So don't reinvent the wheel. If there's a prepackaged solution that's got everything you need already built in, use it. That's what they're for. They're great. That does not mean don't understand what they're doing. You got to look at the template. You got to have somebody that knows what's going on, actually look through the template and see what it does. But they're great. They deploy the same thing every time, so you don't have to take as many notes, and there's not as much potential for human error involved. It takes most of that out. There's still human error that could have happened when the template was built, and things could have changed, but they're great. If you get it to work once, you can get it to work every time after that. All right, so AMIs. So we're going to shift a little bit of focus. The way that templates work is generally someone has built some kind of disk image that they will use for your nodes. If we're talking about cluster nodes, then for Windows, then you've got failover cluster feature installed. You might have other things like a specific piece of software installed. Whatever it is, back in the day, before the cloud blew up, you would have to do things like use DISM to make a system image, and then use Windows publication tools on your domain to push images to new machines as you brought them online. I mean, most like colleges and small businesses will probably still have that set up now. They'll have some kind of one server, and anytime they need to add a node to their domain or their work group, they can just talk to the server that's got the disk images and push that image to the new machine and then configure it either by script or by hand. Now we use templates in the cloud, so there's less you doing it by hand, theoretically. What the templates are based on, though, is something similar to those disk images that we used to use, and those are called Amazon machine images or even Azure disk images. Windows or Microsoft decided to stay with the whole disk image name, so it would be less confusing, I guess. But AMIs, disk images, pick your image wisely. If you pick one, you can get one called Bring Your Own License, where you can talk to the person that made it and they can give you a license, or you can just pay Amazon or Azure and they will pay whoever made the image their cut and then take a tiny bit for themselves. And you can pay, I think Microsoft or Azure is on the hourly basis now. I think AWS just recently rolled out a 2-minute update, pay by the minute features. If you decide to go with an AMI and build your own network and stuff, that's something you can do too. Instead of doing it with a template, which I would recommend using a template, you can still do it by hand if you're trying to, like, say you want to, there's no template that meets your needs, then you can find an AMI that has the software on it, and then you can build your own template and create your configuration that way. But you do need to know what's on the images before you decide to keep them, before those are the ones that you go with. Or even better, you can make your own. You can make your own AMI and then build your own template around it. That's what we did. It works great. All right, so another thing that needs to happen before you guys migrate into the cloud or just put stuff in the cloud is you need to know the pros and cons of the vendors that you're deploying into. You need to know what features are best on what platforms and which one of those features matches your actual use case. So Amazon was one of probably the first big name on the scene in cloud VMs, right? They have had a lot of time to give a whole lot of detail and small configuration options to the end user. That said, they have spent almost no time on their end user interface. Microsoft, on the other hand, has the opposite. They tried to simplify it as much as they could. I mean, you can do almost exactly the same things in Amazon and Azure. But Microsoft's user interface is light years beyond the interface in AWS. At the end of this presentation, I can show you a little bit about that if we have time. I haven't done a whole lot with Google, so I can't give you good feedback on Google's, but Amazon AWS, if you need really fine-tuned network level details that you need to tweak, or if you need a very specific bandwidth for a very specific disk IO and disk size, I would go with AWS. If you need just generic stuff to work and you don't have anyone that's an actual expert in the cloud working with you, I would use Azure because it's a little bit easier on the new end user to actually get up and running in Azure. Right. Some of the questions that you'll need the people that work on this to know are things like, are the disks that we're using on the same physical hosts? From what I know about Amazon and Microsoft's Azure, they are not. When we talked to these guys last, it was a year and a half ago in Azure, and everything was on a storage network. So it's kind of like there's a SAN in the same building, possibly within the same small distribution center in that building, that has access to all the physical disks that they're using, and they just provide physical machines links to those SANs, and then those SANs get exposed as volumes or as disks in the system when you attach them. So they're not typically on the same host. So there's a little bit of latency involved just so that how they've built the storage network behind the scenes. Other things that you need to know are things like, since it is a storage network, what does your network bandwidth, does your network traffic interfere with your storage bandwidth? And the answer to that is it could be. In AWS, there's a setting called EBS, EBS enabled, which if you turn it on, then it'll separate your network traffic. Like it'll put the network traffic on a different actual NIC than your disk bandwidth traffic. So you won't have disk contention when you have high network loads, which is neat. Kind of thought that would be the default, but it's not. But those are the types of things that you need to know. And you need to find a person that has that knowledge, and you need to get them on board before you go and make these things. All right. So another point, if I haven't harped on this enough, I recommend using a deployment template. I think I've killed this horse already, but benefits of deployment templates is if you find one that works out of the box, you don't need to do anything. Just set the IPs that you want and be done. They typically give you access to settings, and you can change them as you go, and they are easy. If you find what you need, then they are easy. You don't have to mess with it. If you don't find what you need, but you find something really, really close, then you at least have a starting off point that you can add to. So any templates that you find, Microsoft has a GitHub repo full of template examples and deployments. AWS has a quick start repo web page that you can go to and find these template deployments. And if you find them, they're open source. You can download the actual software, the code, the JSON files and everything that deploys the template, and you can modify it as you want. Again, it's easy as long as you have the knowledge of knowing how to modify it and what the changes that you would do would imply. I would recommend having someone that knows that instead of just playing with it. Because if you have somebody that's just new to the cloud, that's probably going to backfire. So they're easy if you find what you want. If you don't find what you want, find someone smart enough to fix it to where it is what you want. And they are free. As in, typically you can contact someone and they will give you free deployment time. I think AWS gives you one machine image free for a certain number of hours while you're running it and testing it. And both of the platforms, both Azure and AWS, provide, I think, accounts that you could create that give you a free $150 worth of use a month. You can't create big VMs with that, but if you're just pushing a template, testing it, and then destroying it, as long as you remember to destroy all the resources you create, you won't get charged for them. So you could get by easily deploying a 2-node cluster in the cloud 4 or 5 times in a month for no actual cost. It would run up into that $150 free usage, but it wouldn't cost you over that. You wouldn't actually pay them for that time. All right. Another point, don't abandon the best practices for IT in the cloud. Talked about this a little bit earlier, talk about it again. You still need to do data backups, even if you're doing data replication, even if you're in the cloud, you still have to do some form of data backup. Both Azure and AWS, I'm pretty sure Google too, provide specialized tools for this. There's Azure backup, there's AWS backup, microservices, etc. You need to be able to actually get your deployment set up, and then you need to test it. I cannot test. If you need a specific bandwidth for disk I/O and you need a specific bandwidth for actual network traffic into the VM, you need to test to make sure that your deployment gives you that once you get it running. If it doesn't, then change the size of the VM, maybe change the disk type, and until you get the actual stuff you want for the price you want. They're very configurable, especially AWS. Don't forget to do updates. Don't forget that if you've got medical health records, they've got some kind of health record you need to keep on your servers. Well, there are certain HIPAA compliant things you need to do in order to keep health records. So make sure you're doing those as well. Just because it's in the cloud does not mean it is secured at any means. And one that my stories will expound upon is, if you're deploying into pre-production to test, and then you deploy into production, once you finish your testing and make sure that everything that you've got there works, don't differ the two systems. I mean, in an ideal case, say you're testing in AWS with your 2, 3, 4 node cluster with SQL installed and you've got everything the way that you wanted. If it's in the availability zone that you want it in, if it's in the region you want it in, there's not a whole lot saying that you couldn't just change a couple of IP addresses behind the scenes and make it your production. Or if you built it with a template that just lets you set all of those IPs at the beginning, like ours, then you could completely destroy that original test environment, go to your template again, and deploy it with the new IP numbers so that it'll be exposed to whatever range of IPs you need it at, and then test it once it gets back into the production server, and then push it to production. But they must match. Test on a system setup that's the same as the actual production setup. Seriously. Don't abandon those practices. You really need to follow those. Again, that's them. All right. Second story. All right, so we had a customer a little less, about a month ago, I guess. This was a Windows customer, unlike the last one, which was Linux. This customer, I think they actually used a template, but they didn't. The template didn't do everything that they needed. They wanted it to be. They needed better disk performance, so they decided to go with storage pools in Microsoft Windows Server, right? So basically, storage pools are just a fancy way of saying software RAID for all intents and purposes. But they changed the setup once it was done to include storage pools. Okay, and again, they had a test system, test configuration, test setup that had their cluster, everything working, and then they went to go put it into production, and they changed it by giving it storage pools because it didn't have the disk I/O that they wanted. And they figured if they just put it on storage pools, then it would be better. So the test and the production systems didn't match, and then when they got to production, it didn't work. And they assumed it was our fault because our product works with data replication, and if it doesn't work with a software RAID system, then it won't work. But it does work with this particular software RAID system because it's just a volume, and it works with any volume. So they called us. We told them that can't be right. There must be something else wrong. And 2 days later, They get on the phone with Microsoft once we can't help them because we've already told them that it's not our problem, that we don't see anything being caused by our software. None of the event logs are telling us anything is wrong with our software. There's something wrong lower than that. They finally called Microsoft, and Microsoft walked through their settings with them. It's like the third day that they spent on this problem. The entire time that they're on this problem, they're spending money on their original setup that they had that they're trying to migrate. They spent money for a couple days on their test setup, then they shut that down, and then they've been spending like 3 or 4 days on these large, expensive VMs in the cloud that cost almost as much as the other VMs that they had running. So they're double paying for these things, and they're in a really big hurry. Microsoft points out to them that they did not configure their storage pools correctly, and then helped them configure the storage pools correctly. And that was the problem. The thing that we told them was the problem the first day they talked to us, something lower than us, something volume level. They go back and come to find out that's what the actual problem was. And we could have saved 3 days of headache if they had just listened to us and called Microsoft. Granted, the problem might not have been just calling Microsoft. The problem might have been getting Microsoft on the phone. But you see my point. The point is they had 2 systems that didn't match. Their test and their deployment didn't match. They tried to not listen to the experts when they called them for help, and it kind of bit them. All right, so morals. Things like software RAID, storage pools are complex, just like the cloud. You need some kind of specialized knowledge to tackle. If you don't have it, then find someone that does. Make sure your pre-deployment, your test systems match your actual deployment environment. If you're using a template, don't deviate from it if you're not completely knowledgeable about the cloud platform you're working on. And again, if you call someone for help and they don't know what's wrong and they tell you to call someone else for help, then call those other people for help. If they do tell you what's wrong, then listen to them and fix it. Or spend the time working with them so that you can fix it. All right. Then the last one, we're smart. We figured it out, both of those, within about, I think, less than an hour. If they just listened to us, they could have been out the door with a fix, even though it had nothing to do with our product, within 2 hours, both of them. And they wound up spending 2 days on the first one and 3 days on the second one, just hammering away at stuff that wasn't wrong. I don't know. It seems a little silly to me. All right. So I'm assuming that almost everybody knows how failover clusters and replication works in this group. So I'm going to give a brief primer on this. So what goes on in the cloud for a cluster is you've got 2 VMs basically, one in one region, one in the same region in a different data center, and what we got here. And then you've got some kind of other thing, either a microservice or another server or a disk witness on another server acting as a third vote basically in your cluster. And then you have SQL Server installed and available on your source node, on your primary node, and you have data and stuff being backed up on the other node in live time, either SQL Always On or Data Keeper replication. You will have data in both places. So the idea is that if these 3 things decide that node 1 cannot be reached from the outside for whatever reason for more than a small time span, then they will decide that node 1 is no longer doing its job and fail everything over to node 2, because node 2 has all of the data available. They'll just switch around the IP stuff so that node 2 is now your primary instead of your secondary. That's it. Both Always On and Data Keeper do this. Data Keeper is just faster. It's not limited to SQL, and it can do a whole lot more transactions per second than SQL can when you've got them configured identically. So I don't know why you wouldn't use Data Keeper. It's also cheaper because you don't necessarily have to have enterprise versions of SQL to get this to work. You could have SQL Standard, and it would just work just fine. All right, so other things, if you've got this working in Azure, you'll notice that the picture looks the same. It's got some wording differences, and that's it. That's because it's pretty much the same. If you've got this working in AWS, it's the same as it is in Azure. The names have been changed to confuse the innocent. All right. We do have other things that go on in some setups. Sometimes you do need to do stuff like set up a load balancer to do traffic sorting for you, so that if you've got a primary node, the load balancer is the thing telling you or telling incoming requests where the actual primary node is. But you can, if you've got that set up, it works with Datakeeper as well. We have, like, the AWS template does not use an internal load balancer that does exactly this, but the Azure one does, for example. So things. If you need more information about that, we have that link right there. If you want to write down all 400 letters of that, you can. But if you just want it, then I can go back to it later and put it in chat or something. Just let me know during the Q&A. All right, so I'm going to go to a live demo at this point. This is a live demo of the AWS environment. Once I find my mouse. All right, so a couple hours ago, I kicked off a deployment template in AWS, and I haven't really had time to check to see if it succeeded. Many things could cause it to fail, but I think it's working. It deployed all of these nodes. This is from our template. I connected to the remote desktop gateway, so we can go and look at it later. But for right now, I kind of want to show you guys how to get there and show you how easy it is to create what I did 2 hours ago. All right, so here is one of the links that I'll give you guys later. This is the Datakeeper Quick Start page. This is a template. It's actually 2 templates, but whatever. That deploys this configuration. It creates an AWS virtual private cloud. All right, in that virtual private cloud, it assigns 2 zones: availability zone 1 and availability zone 2, and then configures a remote desktop gateway server through some public domain IP things. It does some routing tables for you and some security groups stuff so that you can talk to it from the outside. And then it has 2 private ones for security so that nothing else can talk to them except for things like your remote desktop gateway box that has security groups tied to it that can talk to it. So it's a second layer that someone would have to get through basically in order to actually have access to your data VMs. And then it sets up 2 domain controllers and then two actual data replication nodes. So we've got a primary node and a backup node, and this template installs SQL into a cluster. It creates a shared storage volume, a clustered storage volume from Datakeeper's primary function, and then starts replicating data over to this backup server. The backup server adds SQL to it as well, so that you can switch over back and forth as you see fit or as needed by some kind of failure. Right? And then it also has a file share witness for your cluster, so it has a 3rd vote on the first DC, on the first domain controller. All right? All of that is set up for you with this template. You don't need to do anything except provide it these IP addresses that you see set here. These addresses are the only things you need. And even then, these are provided for you. So if you just want to use what works and you're okay with having that number as your IP addresses, then you're done. You can change other things like names of things, but that's what you don't need to do anything else. All right, so I'm gonna do a quick demo deployment of this. If I can find my link. I guess I'll see. All right, so when you go to launch one of these things, if you actually wanted to see the code for the template resides here. They give you the actual link on the internet to find, this is a JSON file basically. It's just a declarative syntax file that has the steps needed to deploy the thing. You need to come up here, you need to choose a region that you want to deploy it to, let's say Canada. All right. Still got the link in here, and then you can just hit next. And then basically, these are all the settings that our template provides that you can configure. It's a little bit verbose, but we wanted to make sure it was robust enough to handle all the configuration settings you guys want. So there's a stack name, availability zones. I'm just going to leave these defaults. We did all the subnet masks for you, so you don't have to do anything else. So if you leave these alone, you don't have to do subnet masks. If you want your own, or if you already have one and you just want to like point new things to it, then you can use another one of our templates that will take care of this for you instead. This is the full-blown, huge template that deploys everything. We have another smaller template that just deploys the cluster nodes into an existing VPC, basically. You need a key pair, size for your DCs, IP addresses, names, the name for your new domain. You can change it there, whatever you want the net BIOS name to be for your domain. Some passwords. System, admin domains, admin passwords. I think I typed that right. All right. This would be a wherever your home of operations is. For the sake of this, I put in allow access from anywhere through the jump box. So as long as this is there, anyone can talk to it, but you should put something else in there. Things like, do you want to pay as you go or bring your own license versions? If you already have your license for SQL and you just want to use that, then you can get a license for DataKeeper and we'll work that way. If you don't, you just want to pay for everything on the hourly, then you can use pay as you go. I'm going to use pay as you go, so I don't need anything in here. Again, we're going to use SQL Server. Our template allows you to not install SQL if you want to, or to install SQL. Eventually, we'll have it to the point where you can install a specific version of SQL onto a specific version of Windows. But for right now, this is how this is going to work. We got sizes for the actual cluster nodes, IPs for the cluster nodes, and we're done. We're just going to hit next. It's going to scan the template to make sure that everything was good. It was, and I'm just going to hit next. Accept that these were the settings that I wanted to use, and move forward. That's it. It's now pushing all of that, and we can just have a cup of coffee. So I'm going to go look at the one that we already did. For example, we've got this remote desktop gateway box that we're going to log into. So give me a second. All right, so let's see if we can get this working. I think that's the right IP address. All right, so again, this is just the primary node. We can bring up failover cluster eventually. Seems to be taking a good bit of time. There we go. All right, so here's the data keeper volume that the template set up. It's now cluster storage. And if you look at installed SQL Server already onto that, using it as storage, oh, there's no more available, right? All right, so that's it. I mean, basically the idea here is you would put that template together, you would set out those resources, push it, come back 2 hours later and have this. All right, so at this point, here are some of the links that I've got for you. If you need SIOS Data Keeper, or if you need template stuff, our AWS template is here. Our Azure template is at this GitHub repo. If you need our AMIs, or if you just want to check them out, they're both at both of these places. If you have any other questions, we're going to turn it over, and we're going to have both, I think Dave and Mike are online, and myself. So if there are any questions, now's the time to ask.
All right, thanks, Heath. One question somebody asked was about the templates, the deployment templates. Just wondering, do they need to purchase licensing for the SIOS Data Keeper, or is there a free trial, or how does that actually work to test the waters?
Right now, if you go to the AMI and the template are free for a certain amount of time. I can find my link to that again. All right, so the way that it usually works is if you wanted to use the BYOL, you can contact us and we can give you a 2-week license to use the things. So instead of having, back when we were doing that configuration a minute ago, there was a place where you could choose BYOL or pay-as-you-go. If you use BYOL, it'll install a temporary version of SQL, and then you can put your license on it there. If you use BYOL for Data Keeper, then you can just contact us. All of our contact information is on the bottom of the AMI pages. You can get a license from us that way. If you want to do pay-as-you-go, I don't believe we have a free one yet because they only do one free node at a time. Like, you wouldn't be able to deploy an actual cluster for free that way. You'd have to use the bring your own license method to get a free trial.
All right. Let's see, another question was related to a comment you made earlier in the webcast about, there's a lot to configure in the cloud and things can go wrong, as I guess you led to some of the examples. So just wondering, do these templates actually kind of alleviate some of those issues, that some of the things you had talked about, if they just use the templates?
Yes, I mean, that's why we made these, actually. We made these templates because they've got some configuration in there, enough that you can have a custom deployment, but they get rid of all of the network headache. They create all the routing tables that you would need. They create all of the security groups. They set up any inner regional stuff that you need set up, or inner zone, not region. If you've got any networking stuff is already set up in the template for you. So theoretically, you launch it, you've got a full-blown cluster with your domain controllers, like we looked at a couple minutes ago. Here, you've got this basic setup, like all these VMs. You get, well, right now it deploys one unless you ask it to deploy more than one, and then 2 DCs and then 2 actual VMs. You get all of this deployed and all of the networking and stuff deployed without any other headache that you need. So either of the customers that I talked about earlier, if they'd used our template, they wouldn't have had a problem. It would have just worked. The problem came with the second one when they used someone's template. I don't think it was ours, but it was close. They deployed a template and then added our product on top of it, and then broke storage pools. So it alleviates a lot of the problems, but we don't have that one. Like, configuring storage pools is not actually an option in our template. They just needed to find someone that knew how to do it before they tried to do it.
Okay. Another question a few people asked, again, just the contact information, how to get in touch with you or with Dave or Mike. Could you just share that information again, or if you want to go to that slide, or if the last slide has information?
Sure. Here you go.
Okay. So they use that email address right there, that it'll get routed to one of you?
Yep.
Okay. All right, great. Another question somebody had was, do the templates, I think they're talking about the templates, but do the templates work with SQL Server 2008 R2? Or which version of SQL Server are the templates for?
Right now, all of the templates use 2014. We're in the middle of putting 2016 on there, but I don't know of any plans on putting 2008 in the template.
Okay.
That being said, if you know someone that knows how to install 2008, the actual command lines are not different. There would be a very minor tweak to the thing to get 2008 to work.
Okay. And then with that too, SIOS Data Keeper works fine with SQL Server 2008 R2?
Yes, Data Keeper works completely fine with 2008 R2 and later.
Okay.
Yeah, I'll add some flavor to that. So SQL 2008 R2, oh, this is Dave Birmingham, by the way. SQL Server 2008 R2 does not support cross-subnet failover. So in AWS, where you're failing between availability zones, those availability zones are in different subnets. So traditional Microsoft failover clustering does not work with SQL 2008 R2 in AWS. We do have customers, though, using our product called the SIOS Protection Suite, which is essentially an HA alternative to failover clustering that also leverages the same data keeper replication engine. And that has more flexibility to allow you to deploy SQL 2008 R2 in a cross-subnet failover configuration. So that's the only caveat with SQL Server 2008 R2 you need to be aware of. Azure doesn't have the same restrictions because the different fault domains and the upcoming availability zones that they just announced at Ignite are going to be in the same subnet. So you'll be able to use the Microsoft failover clustering with Data Keeper in the Azure environment for SQL 2008 R2.
Okay. All right. Another question somebody asked was related to the templates, and just wondering, is there any type of templates that they can do this similar setup on a on-premises configuration for testing, or is this only available for the cloud?
This is it's actually a complex question. The Azure template, I believe, does have a little bit of flexibility as far as the internals of it. You can deploy the PowerShell scripts from the Azure template on premises without really monkeying with them. You just have to know how to deploy things for the desired state configuration engine that comes with PowerShell. And then you could use the little DSE modules that we include in that template for that. The AWS one, though, has more scripting that is done on I guess kind of like a scripted command line sort of way instead of the DSE module push. So you would have to get all of that and then look at the order that it's done in the template, and then you have to like basically write a batch script to run the things in the same order locally. But all the scripts that put that together are available in the template backend if you find it and download them. But it would not be a trivial thing from the AWS side. It really isn't a trivial thing from the Azure side either, but it would be easier.
Just to add to that, Microsoft just GA'd Azure Stack, which this really is one of the primary use case scenarios where you can deploy Azure on-premise, and then that way you can leverage all the work you've done with these deployment templates, whether you're deploying on-premise or in the cloud or on a cruise ship. It doesn't matter as long as the platform is Azure or Azure Stack. It's the same experience both on-prem and in the cloud. So we really are excited to see the uptake of Azure Stack and having people leverage all the work they put into deployment templates to deploy on-premise as well.
Okay, and just to follow up, so it sounds like the Azure side uses PowerShell scripts, and then secondly, are those scripts available for download, or are they just kind of embedded in the templates? How does that? Can somebody see those PowerShell scripts? I guess I'm asking.
Sorry, I was having phone difficulties.
Yeah, I'll defer to Heath on that. He wrote these, but I'm pretty sure you can choose those right from the deployment templates and see the code behind the scenes.
I'm sorry, could you repeat the question? I was trying to get my phone off of mute while the last bit of the question was getting asked.
Sure, sorry. So you mentioned that the Azure side uses PowerShell scripts. So someone just wondering, are those PowerShell scripts available that they can download and look at them, or they have to go through the template to get access to them? Just wondering if they're accessible.
Yes, because actually both of the templates are available completely and totally. They're just easier to find with the Azure version. If you go to that GitHub link at the very bottom, the last one, that has all of the PowerShell modules and the scripts inside rather well-organized folders. You might need to look into the actual template to see how they're used, but the command lines for the actual scripts and everything are actually in the template.
All right. Well, there's no other questions. I'm not sure there's anything else you want to add, Heath or Dave, before we wrap things up.
Nope.
Dave, anything?
Yeah, I mean, just kind of going back to the original question about the example that Heath was saying about the storage pools and the issue there. In case anyone's wondering what the real issue with storage pools is, best practice would be that you enable a storage pool before a cluster is created. Because once you create a cluster and you're trying to add a storage pool after the fact, it thinks it wants to be a clustered storage pool, but in reality, that's not supported unless you have the shared storage. So things kind of go haywire there. And so there are documented steps on making that work, enabling a storage pool in a cluster. But if you didn't, find that knowledge base article, you probably are going to have problems. So just be aware of that when you're putting together some storage pools.
It's a good point, Dave.
All right, well, we're going to wrap things up. So thanks, Heath, for sharing all that information today. And I also want to thank SIOS for sponsoring today's event. The webcast was recorded, and you'll receive a follow-up email with links to view the archive, as well as to download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MSSQL Tips. Thank you for attending, and have a great day.